Okay, so today's lesson is big on the vocab. We are going to overhaul all of your vocab for geometry. You've probably seen these things before, but we're going to get real specific. The most important piece that we're going to talk about today is notation. On your quizzes, on your tests, I'm really going to be honing in on your notation. You will get points off if your notation isn't perfect. So, we're going to pay attention to that notation today. I'm going to make a note at the top of my page that says notation, just to remind myself that that is what we are really focusing on today. And again, you've probably seen these things before. The word point should not be new to us. We've probably seen points before. If I look at a diagram, a point looks exactly how you think it should look. And the definition of a point is a location that has no shape and no size. We're focusing on this notation. There are two main ways that we can name a point when it comes to like a diagram or a word problem or whatever. We can either use a capital letter, okay? So just a capital letter represents a point, has to be capital. Or we can get more specific and we can write point A. I don't like the way that looked. Okay, capital letters all the time for points. The next guy that we're going to talk about is a line. A line is kind of drawn like this. What I want you to notice about a line specifically is that it has these arrows on either end, and that is because by the definition of a line, it is a series of points that extends in opposite directions without end. Those arrows on the ends indicate that they keep going on forever and ever and ever in these directions. So lines are made up of points. Therefore, we can name lines based on the points that they contain. If we remember what we just said about points, points are always capital letters. So if I want to name this line based on its points, I'm going to pick 2 points on that line. I could call this PR. And I indicate that it's a line by putting a little line with 2 arrows on the top. So PR, that encompasses that entire thing that we see there. I could use a bunch of different combinations of the letters that are on this line. So another perfectly fine example would be QR. Or you could do QP, right? All of those things work as long as they are 2 letters and they lie on that line. Now, this way is kind of like a description of what that line contains. I can look at those names and say, yeah, I know it contains points P and R and Q, right? Another way that we can name lines is sometimes lines have their own names. Just like I have a name, you have a name, lines also have names. You are going to see those names are lowercase, usually italicized letters. We can use those to name our lines. So for example, this line is called line M. We have to include that word line, and we're going to use that lowercase letter to indicate its name. Any questions on that? Okay, our last big piece here is a plane. A plane is a flat surface like the floor, the wall, the ceiling. It is made up of points and lines, and it extends infinitely without ends in all directions. So even though our plane here is drawn like a sheet of paper, this plane will keep going on and on forever in all those directions. The way that we name planes, again, we can use the description of this plane, so talking about what kinds of things it contains. So I can call this plane, have to have that word plane, DAC. Those are 3 points that are contained inside of that plane, DAC. I could pick other 3 points. Plane, let's say BDC. Okay? Any 3 points on that plane work, except I have one exception. And I'm going to make a little angry face over here. We cannot use 3 points that are on the same line to name a plane. So I could not call this plane BAC because they form a straight line. Any questions on that? We have one alternative way to name these planes. Just like lines have names, planes also can have their own names. They are usually indicated in the corner of your plane, and it's usually a capital, italicized, or curly letter. So this plane could also be named plane K. Any questions on that? Next is space. Space is a term that we kind of just use willy-nilly. We don't really talk about it too much after this, but just imagine that is the boundless 3-dimensional set of all possible points. So when you are seeing graphs and diagrams and stuff in this unit, you have to imagine that they are 3-dimensional. They can contain lines, planes, points, all that good stuff. We don't have any notation, it's just space. Okay, now we're going to get into some more descriptive words here. The first one is collinear points. We're thinking about that word collinear and how it breaks down. If you think about co meaning together, linear meaning on a line, collinear points are points that lie on the same line. So for example, I have these 4 points that I can see right in here that all lie on the same line, V, W, X, Y. So I could say V, W, X, Y are all collinear points. The opposite of collinear is non-collinear. Okay, again, that means they do not lie on the same line. In order for points to be non-collinear, we need at least 3 of them. At least 3 points. Because if you think about it, I can draw a line between any 2 points, in the world. If I pick a point over here and a point down here, I can draw a straight line through those 2 things. So to be non-collinear, there has to be at least 3 points. So if I take a look at this diagram right here, I could say that points W, Y, and Z are non-collinear. Right? W and Y do lie on the same line, but because we got Z, we know that those 3 things are not on the same line. And there's a bunch of different combinations here, but we'll just talk about one. Any questions on that? Okay, next is coplanar points. Okay, coplanar, again, co meaning together, planar on the same plane. Those are points that lie on the same plane. There's a bunch of them in this one example here. I see V, W, X, Z, Y. All of those guys are coplanar. Then the opposite of coplanar is non-coplanar, points that do not all lie in the same plane. Similar to how you can draw a line through any 2 points, you can draw a plane through any 3 points. So for something to be non-coplanar, we need at least 4 points. You can draw a plane through any 3 points. So for example, I could say, look at this, Z, X, Y. All of those points lie on the same plane. But as soon as I add in T, I am no longer coplanar. I cannot draw a plane through all 4 of those points. So let's say T, X, Y, and Z. Maybe we make ourselves a note. It is very tempting because that plane is not drawn in here to want to say, oh yeah, T, X, Z. I can clearly see that T is up in the air, so they don't lie on the same plane. But we have to remember that you can draw a plane through any 3 points, even if it's not drawn on our diagram. Any questions? Okay, flip it over. Just like we have coplanar and non-coplanar points, we have the same idea for lines. So 2 coplanar lines are lines that lie in the same plane. We're going to get some practice naming our lines here. I'm going to call this line right here, it has a name. I'm going to call it line N. And one that is coplanar to line N is this guy right here, which does not have a name, so we're going to have to use its description. I'm going to describe it as line XZ. Questions on that? Cool. Non-coplanar lines, again, pretty self-explanatory. They do not lie on the same plane. This one is like kind of harder to visualize. We have to imagine that you can't have like bendy planes. Our planes are flat and they are straight. So if you think about a piece of paper, sure, you could have a piece of paper that twists, but not planes. Planes would not go straight through both of those lines. Does that kind of make sense what I'm saying there? You can't twist your piece of paper to make a plane. So these 2 lines, they are drawn on 2 separate planes. Line A and line B, they are drawn on 2 separate planes, and we cannot, let's just do line. And we can't draw a plane through them. So line A and line B are non-coplanar. Good? Okay, some more stuff. When things intersect, here's kind of what they look like. Planes and lines, sometimes they don't intersect at all. One is floating above the other. Sometimes I imagine like a piece of paper and you stick a pencil through it. That is called a plane intersecting a line or a line intersecting a plane. They intersect at a point. So a plane and a line always intersect at a point. If it says the line is contained in the plane, that means that line, oh my goodness, is like fully flat on that plane. Like so. Oh, that's a terrible color. Does that make sense? So intersecting means it's going straight through. Line contained means it's like flat together on that plane. When 2 lines intersect, they form a point. Okay, that is true whenever 2 lines intersect. They always are intersecting at a point. If they do not intersect, we call those lines parallel lines. 2 planes intersect at what? What does it look like? When 2 planes intersect, what do they form? What does this look like here? Is it a point? It's a line. 2 planes always intersect at a line. So maybe I go and write this out. Maybe I'm going to say plane ABN and plane, what's another one? ACD intersect at line AB. Okay, the same thing is true down here. These 2 planes are intersecting at a line. You will never have 2 planes intersecting at a point. Always a line. Questions on that? Okay, couple examples. When we are doing this stuff, obviously, your way of naming something might be different than somebody else's next to you. As long as you have the correct notation, the points that you pick don't matter too much. So we're going to see here there's probably a couple different ways we can do this. So in letter A, it says use the figure to name a line containing point K. Here's K. Can somebody give me a way that we can name this line? There's a bunch of them. Yep. Line A, that's its name. We see that's lowercase. Now I can go off the description. What are other ways that I can name that same line? Casper? Yeah. Two of the points that are on that line, J and K, that works to name it. I can keep going with these combinations. I can say that this line is called JL. I could say my line is called KL. I can flip those and write them in a different order. There is a ton of options here. What I don't want to see is something like this. What's wrong with this? We need 2 points instead of 3. So try not to do this. You would get points taken off if you wrote JKL as a line. Lines only need 2 points. Okay, use the figure to name a plane containing point L. Remember, we name planes with 3 letters. So I'll start us off here. I could call this plane JLM. Anybody got another way we can name this plane? Yep, Hannah. Plane B, that's its name down here in the corner. What could I not call this plane? What would be a big no-no if I tried to name this plane? Yeah. KL, not enough letters there. What about plane JKL? Why couldn't I name this JKL? It's got 3 points. Dahlia? Yeah, we cannot use 3 points that lie on the same line. So because JKL are all on the same line, this is not a proper way to name a plane. Okay, they have to be in 3 non-collinear points. Okay, perfect. Next diagram. Name 3 points that are collinear. I think there's only one option here. What is it? Where are my 3 collinear points? Yeah, Casper. ABD. Those are the only ones that are collinear. Okay, letter B. Here's something that's going to pop up on your homework that we haven't really talked about yet. These, when they don't have arrows on the tops, we call those segments. Okay, so right now this is saying segment DB and segment CA. A segment is something that stops at the point. So if I have, let's draw this out. I'm just going to do an example here. If I have X, Y, Z, and I said segment XY, I'm talking about exclusively this part right here. Does that make sense? So if it has no arrows, it's talking about a segment that has endpoints. If it has arrows, it's talking about that entire length X, Y, Z, and so on and so forth as far as it will go. So these should technically have arrows on the top of them because we're talking about lines. I think they just did not print. Okay, because when I'm talking about DB as a line, I want to talk about this entire thing here, not just this segment. Okay, so then let's finish it off. What point do they intersect, DB and CA, those 2 lines? Do we see? Here and here. They come together at this point right here, point A. And remember, we have two ways to name points. We could call it point A, or we could just call it A. Questions on that? We're going to do one more where we draw. So flip it over. Ooh, my goodness. Flip it over to page 3 here. There's a lot of instructions on this one little problem. So it says, draw and label a figure of the following situation. Plane R contains lines A, B, and D, E, which intersect at point P. Add point C on plane R so that it is not collinear with A, B, or D, E. Here's how I like to tackle these problems. I start from the biggest picture, okay? A plane is bigger than a line, which is bigger than a point. So I start with the planes. Plane R. We draw planes as like flat sheets. Maybe it's like a parallelogram for you. I'm going to name it R, and our names are capital letters, and they go in the corner. Then I'm going to start getting more narrow. So now I need to draw line AB. Remember, we use AB as descriptions of that line because it contains points A and B. So when I draw this, I'm going to draw a line. I'm going to make sure it has arrows on it. You will get points taken off if you don't have your arrows at the ends. And it's got to contain point A and point B. Then I got another one. I have line DE. And if I read a little bit further, I can see that those two lines are supposed to intersect. So I'm going to make sure that when I draw these, they intersect somewhere. Now I'm going to get a little bit more narrow. Now I'm going to focus on those points. My next instruction is that they intersect at point P. So right here, I give it a little label. That's point P. And then last but not least, it says add point C on plane R so that it is not collinear with lines A, B, or D, E. So where am I going to put point C? Maybe it's more helpful to say, where am I not going to put point C? Casper? On a line. If it's non-collinear, it cannot go on one of those lines, but it could go literally anywhere else. So there's point C. Any questions on this? Okay. If you look at the next page, we're not going to go through this, but it is kind of helpful and useful. Maybe you want to do it. This is a page that kind of focuses on that notation. It's really good practice. So what it is here is a picture of your definition, the name of the term, and then a correct label. And then it goes through a bunch of different options talking about why is this incorrect notation. So for example, if I looked at like this guy right here, why would this lowercase t not be an appropriate name? Any ideas? Why could I not name this just T? Yeah. Yeah, because we need the line in the front. So that's good practice. If you would like to use it, that's totally optional, up to you.